So welcome to the first of the problem solving sets that I'll be going through here for the biochemistry. My aim in these problem sets is not to give you things that are additional beyond what are in the lectures for the course, but rather to help you to work through problems that students commonly encounter in biochemistry. There's no aim in providing additional work, and if they're helpful to you, great, and if they're not, then that's fine too. So the first set of problems that I want to work through are things that relate to things commonly in solution. And some of this, I understand, is a review of freshman chemistry. And one of the most basic concepts relating to the issue of solutions and aqueous solutions is that of pH. pH, of course, is a measure of the hydrogen ion concentration. And as you can see from the equation on the screen, the pH is equal to the negative log of the hydrogen ion concentration as measured in molarity. I won't go through showing basic math because I'm assuming at this point you've gone through basic math, but I do want to review a bit of the freshman chemistry. The another equation that we'll be using throughout these problems is that of the pOH, which is not surprisingly equal to the negative log of the hydroxide ion concentration, as you can see here. And the third principle I want to illustrate to you is that, of course, that pH plus the pOH is always equal to 14. Now, these equations are very, very useful where we have strong acids and strong bases. So a strong acid, of course, is something like HCl. If we take HCl, hydrochloric acid, and put it in water, it completely dissolves, meaning if we start with 1 mole of hydrogen chloride and we put it into water, we will end up with 1 mole of protons and 1 mole of chloride ions. The chloride ions won't factor into our equation in any way, so for our purposes here, we can essentially ignore them. Strong bases like sodium hydroxide behave in exactly the same way. So if I take 1 mole of sodium hydroxide and I put it into an aqueous solution, I'll get 1 mole of sodium ions and 1 mole of hydroxides. Well, the hydroxides, of course, are relevant for our OHs, as we see here. In this case, the sodiums won't enter into the equation at all.